Welcome back everyone to this lecture on Seaborn. Seaborn is a visualization library built using matplotlib that focuses on creating standard statistical plots with a simple one-line function call, and it works especially well with the pandas data frame. This comes at the cost of less customization options than pure matplotlib. So keep in mind, you're not going to be able to customize every Seaborn plot exactly how you see fit through straight Seaborn parameter calls. Sometimes you'll have to reach into matplotlib to actually work with the plot for further customizations. So as I mentioned, you can still affect plot attributes created in Seaborn by adding pure matplotlib.pyplot calls. For more information on the full depth of the Seaborn library, you can visit the official online documentation at seaborn.pydata.org. For now, let's head over to a Jupyter Notebook and show you the very basics of how to create statistical plots with the Seaborn library. Let's jump to a notebook now. Okay, here we are at this Jupyter Notebook. To begin working with Seaborn, what we first need is a data set. So, if you actually look under the Visualization Crash Course folder and then open up Seaborn Basics, the notebook that corresponds with this lecture, we have a full rundown on the data we're going to be using. And we're actually going to be using a medical data set that has a bunch of information about patients and then whether or not they have the presence of heart disease. So we can see here we have their age in years, their sex, male or female, chest pain type, cholesterol levels, etc. So if you want information on what all these columns represent, the information's right here for you. But keep in mind, this data is located under our overall data folder. So you're going to make sure to read that in correctly, and then you should be able to read in that data frame. Pay careful close attention to your actual full file path when reading it in. So I'm going to say my data frame is equal to pd read CSV, and I'm going to, since I'm located in the exact same location as the actual Seaborn Basics notebook, I have to go out one, then reach into data, and this file is called heart.csv. To begin working with Seaborn, we import Seaborn as SNS. So let's discuss just a few of the basic plot types. There's a distribution plot, which is essentially a histogram. And if we call sns.distplot, we can call it on a single column, and it will show you the distribution of the data. So if I say df age, this will show me the actual distribution of the overall age data. It has both a kernel density estimation, which is this line, essentially estimating what a probability function would look like for this data, and then it has a histogram. If you want to turn off this KDE line, what you can do is say KDE is equal to false. Run that, and then here we see our actual, essentially, histogram. A histogram is essentially just a count per bin. So I can see here that I have these what look like columns. Well, each of these is actually a bin, and the y-axis is defined by how many counts fall for the left side and right side of that bin. So for example, here on this kind of really tall bin, the tallest bin there is, it looks like there's about a little over 60 count. And that means that for this range in the bin, so it looks like ages maybe something like 58 up to 60, there happens to be around 60 people there. Now if I want, I can affect the bins by saying number of bins is equal to, maybe I only want 2 bins. In which case, if I run that, now I just have 2 bins, which essentially goes from a little less than 30 to kind of midway around maybe 54. And then the count there is somewhere between 100 and 125 points. So obviously, depending on the size of your data set, you can affect this number of bins, which in turn affects the actual width of the bins. Now keep in mind, if you start asking for too many bins, for example, let's make this something like bins is equal to 50, you'll end up with lots of empty spots because there happens to be no data points for that particular bin. Okay, now if you do want to change the size of this plot, what you can do is make a call right before this Seaborn using matplotlib by saying plt.figure, which essentially calls the underlying figure that Seaborn is working with, and then say fig size is equal to, and then you pass in a tuple of how large you want the figure. So I can say something like 12 by 8, and this will resize this to 12 by 8 inches. And we can kind of stretch it out if we want to. So for example, if I made this 3 by 15, you can see how that is stretched out. So this 3 representing kind of along the x-axis, this 15 representing the y. Okay, so other things we can do here, let me turn this back into a more normal looking plot. Let's just say 8 by 8. Other things I can do here, in fact, we can make it a little smaller, 8 by 4. So other things I can do here are set the color. So I can set color strings, just as we mentioned before. So I can say something like the color is red, and I can also play around with the bin size. If you do Shift Tab here and expand on this, it will show you the various other things you can do, such as different fittings for the KDE, different labels, etc. But keep in mind, most of this is designed to be just very simple calls. In fact, you'll notice that the X label, or the label for the X-axis, was automatically determined from the name of the data frames column. So now let's go ahead and show you a count plot, since we'll be doing that as well. If I take a look at the head of my data frame again, here maybe I'm interested in the count of the label, essentially the target, whether or not they have presence of heart disease, per sex, male or female. So I can say sns.countPlot, state that I want the X to be equal to the sex feature, and then say my data is equal to this data frame, df. Run that, and essentially what this does, this is essentially a group by whatever you have on the x-axis for a count call. So this shows you the counts for, in this case, x is equal to sex. So how many males you have in the data set versus how many females. Then we can do this same thing for the target, which is really important actually. Later on in machine learning, we'll see that it's usually a good if you have balanced classes. So here I have roughly the same amount of 0 targets as I have 1 targets. Then we can do other things like CP, which if you go back to the actual notebook, you can look this up and see that it's like chest pain type. So there's actually various types of chest pains, and we can see the count for that as well. Now maybe you're interested in the types of chest pains, not just the count, but count per sex. So what's really cool about Seaborn is you can add this hue call and add another categorical feature, such as sex, and it will then divvy this up not just by the pain type in their chest, but by the hue. So it'll show you for both male and female per CP. Okay, now the last thing I want to show you is that you can actually affect the palette here. So if you don't like these colors, you can say palette is equal to, and then you can pass in a string code that corresponds to the color mappings that are available in Matplotlib. And if you take a look again at our notebook and scroll down, we discuss this right here, where we essentially provide you a link to all the color mappings. So you can add colors based on the color maps. Sometimes certain color maps don't make sense for every data set. You want to be careful. For example, here it looks like we're dealing with categorical data, so it might make sense to deal with category-based color mappings. So if you come over here to choosing color maps in Matplotlib, as we mentioned, Seaborn is built directly off of Matplotlib. Simply scroll down here. Here it sees all the code, but this is actually the colors that we can use. So there's sequential color maps. There's 2 types of sequential color maps. There's diverging color maps that go from one color and diverge into what is kind of like an opposite color. There's cyclic color mappings. There's qualitative color maps. These would probably be good choices for things like categories. And then there's just miscellaneous color mappings. So here are all the string codes that correspond to those as well. And you're free to choose whatever you want. So we'll come back to Seaborn Basics and recall, for a lot of these Seaborn commands, you affect that by choosing palette. All right, the next plot type I want to share with you is known as a box plot. And I'm going to quickly explain what the box plot is. In our Seaborn Basics notebook, we have this little image here of a single box plot. So if you already know what the box plot is, go ahead and kind of fast forward for this part. But I'm just going to quickly explain the basics of what this is trying to display visually. What the box plot attempts to do is show you the distribution, and specifically the distribution across different categorical features. So here we see just a single box plot, which shows just a single distribution. And what this does is it splits up the data into 4 equal parts. So here we have these different percentiles, and we have right here in the middle this what's known as the interquartile range, the data points between Q1 and Q3, where Q1 is the 25th percentile and Q3 is the 75th percentile. So essentially what that means is the middle 50% of all points. So if you had 100 data points, then the middle 50 points are in between somewhere in this box. This line in the middle of the box then splits up all the points in half. So 50% of the points on one side of the median, and then the other 50% of the points on the other side of the median. Then we have these minimum and maximum values, which are calculated with the interquartile range. So these are often known as box and whisker plots because we have these whiskers extending off of that middle 50%. And this minimum is established as Q1 minus 1.5 times this interquartile range. And then we decide that anything outside that particular minimum or maximum, based off that interquartile range, are going to be outliers. So then we just label those as points. Okay, so now let's build our own box plots and see why they can be useful. I'm going to head back to our notebook that we've been working with. What I'm going to do is call sns.boxplot. And let's set the x-axis to sex. And then I want to see the distribution of age across this category. So again, for box plots, the y should be a continuous feature. The x should be a categorical one. And then we just need to say data is equal to df. And now I can see the distribution of the ages across sex 0 and sex 1. So here we can see that it looks like sex 1 on average tends to be a little younger than sex 0. Now what I can also do is start kind of comparing other things. Maybe I want to compare the actual target, again this is categorical, 0s and 1s, against a feature. So one of the features could be, if we look back at Seaborn Basics and come up here, there's this maximum heart rate achieved feature. So let's go ahead and kind of copy that one in. We'll come back here and set that as our y. So then we run this, and now we can compare the maximum heart rates achieved for people with the presence of heart disease versus not having it. And it looks like there's kind of something different here between them, especially between the averages of them. Okay, then maybe I want to add a hue here to see how this is affected by sex. And what I can do is say hue is equal to sex, and now I can see not just the heart rate per target category, but the heart rate per target category per sex. So now I have these 4 box distributions that I can play around with. And if you want to see more examples of this, you can definitely check out the Seaborn documentation. I want to show you 2 more things, which are scatter plots and then a pair plot, which is essentially a scatter plot for your entire data frame. So let's show you what a scatter plot looks like. You should already pretty much be familiar with scatter plots if you have some interest in machine learning. But essentially what this does is we pass in some feature along the x-axis and some feature along the y-axis. So here I'm just doing some sort of beats per minute feature, and then state our data, run that, and here we can see a scatter plot. So essentially for each data point, we just grab these 2 values and put a point on the map. So what I can also do is start adding in hues to color points differently based off a category. Again, maybe I can choose sex for this. And then what I can also do is start playing around with the palette. So maybe I want these to be colored differently. I can say palette is equal to dark 2, for instance, and then I can see these results. So if you're colorblind, you may want to play around with the palette until you can distinguish the points correctly. And you should also be keeping people that are colorblind in mind when you're performing visualizations that are dependent on color. And finally, what we can do is we can also change the size of these points based off a feature. So for example, I can say size is equal to age, and you'll notice that the larger the point is, the older that particular person is. So as we begin to play around with these visualizations, we can actually display a lot of feature dimensions on a 2D plot. So here we're actually showing not just this beats per minute versus this cholesterol feature, but we're showing also the sex and the age. So lots of information here on what is actually just a simple scatter plot. So very useful. And then last thing I want to show you is something called a pair plot. Often when you're dealing with a smaller data set, such as the iris data set, so let me load that in. We'll say iris is equal to pd read CSV, and then we'll say data iris.csv. So the iris dataset is probably something you are familiar with. Essentially shows you 4 features of flower petals and sepal lengths and widths, and then the species of flower it actually is. What you can do here is you can call sns.pairplot, and then you just pass in either an entire data frame or a subset of data frame columns, run that, and what Seaborn will automatically do for you is the following pair plot. And what this does is it creates a histogram of each of these features along the diagonal here, and then performs a scatter plot for each comparison. And you should note that for some of these, essentially along the diagonal, you should get duplicates. So for instance, here we can see petal width versus petal length, and it looks like there's a strong relationship there. And if you keep going across the diagonal, you'll notice it's actually the exact same plot, petal width versus petal lengths. So it should essentially be mirrored across this diagonal. Now there's lots of different options here you can play around with. You can start adding hues. So for example, you can say, give me the hue per species of flower. Run that. And then you'll see the actual, it'll change the histograms to be KDEs, essentially kernel density estimation plots or distributions of these actual features per species. So this is a really nice way to quickly get an understanding of all your data. But you should keep in mind that the larger your data frame, especially on number of rows and number of columns, the larger this pair plot's going to be, and it's going to be harder to interpret, and it's going to take Seaborn longer to actually develop it. So don't just run pair plot on huge data frames. Otherwise, your Jupyter Notebook will be stuck all day waiting to render this giant plot that may not be useful to you. Instead, maybe try to select subsections of the plot based on some sort of analysis of the data frame beforehand. And keep in mind, you can always just perform your own histograms or own distribution plots or your own scatter plots for any combination of features you're interested in. Okay, thanks. And coming up next, we're going to set you loose on some exercise to test your new Seaborn and Matplotlib skills. I'll see you there.